So in part one of this customizing a P5 application video, I was explaining how a lot of the metadata works, and I think I was talking about the animation URL. Um, so yeah, there's a requirement for displaying it on OpenSea and probably everybody else now because I'm sure they all do it the same. Where we have to point to some backend server that's going to return this animation URL, and I explained how in our case we're generating the data as part of this JSON payload on chain in this generated URL field. So really all this is doing, we use Cloudflare for our backend, and so we just have a Cloudflare worker function that's the target of this URI on line 21, and when it gets called, the first time that it gets hit, it will just retrieve this generated URL directly from the JSON metadata, and that's what it will return. It'll make a copy of that. There's lots of ways to do that really efficiently inside Cloudflare. So and we're going to publish that worker. So theoretically, you can eliminate us completely from your NFT. Maybe you're a large company and you don't want to have any dependency on us in any way. Well, you can do that because you can set the animation URL and do the exact same thing that we're doing, because the data is available on chain basically as part of the JSON payload. So, and it's the same thing for the image data, which is generated on line 7. In this case, we can't generate this image on chain because it's generated by the p5 algorithm. So what you have to do is you have to actually run the p5 algorithm and then take a snapshot in order to generate this thumbnail image. So again, we do that for you, and if you want, but we'll have the code for that published also. And so if you don't want to depend on us or depend on our servers, you can eliminate that by doing it yourself if you want. So you can just see the flexibility that we have for when you have an on-chain programming language that's generating the JSON payload for an NFT. There's so much flexibility, and this can be, that's why it's trivial for us to support multiple JavaScript libraries, because it's very similar, what the HTML that you have to generate, and you're not restricted to these. It would be trivial for you to add any other method that you want to use. If you want to use like straight WebGL or something like that, it's very easy to do that. So with all that said, I'll go into how Guive works a little bit and show you some things there. First, it's a Lisp dialect. So if you haven't used Lisp before, it's fairly easy to understand. Lisp is a very old language, maybe the oldest language, but there's only one syntactic form in Lisp, and that's a parenthesized expression. So that's why you see a lot of parentheses when you look at Lisp. But if you look inside any of these parentheses, it's a list of terms, and the first term is a primitive or a method or an operator, depending on how you want to view it. So if you know what the first term is, then you know what's going to happen when that expression gets executed. So one side note on a lot of our operator names, we choose what look like very cryptic names, and they're all very short. And the reason for that is this Guive script is going to get saved on chain at some point, and that costs gas to do that. So you want to keep it as small as possible. So whenever you're using variable names or anything inside a script, you should probably keep them small. And most of our operators are 2, 3, 4 characters maybe. So a lot of the statements that you see in line 1 through 7, they're using this it's called I think we even call it a special operator. There's just a lot of fields that you may want to get or set from our environment, and that's what this operator does. It has an index that you pass it, and that tells it which field you want to get or you want to set. So you can look in the documentation for what a lot of these mean, but so we're like in 4 through 6, we're getting the seed token and the contract, and 3 is setting the name of the field that we want to use for this HTML data that's generated in lines 9 through 19. So and then there's 2 stream operators. One is on line 7, the 2 greater thans, and then the other one you see on lines 9 through 19, which is the 2 greater than with the H for HTML. So these generate the payloads that are going to be put in the JSON metadata. So for the first one here, the image data, the only thing we're putting in it is the URI. So and these streams, they're arrays of strings, and so you set them, and the arrays, I think they're 24 for each one, and you just give it the index of the string that you want to set, and then the rest of the statement is going to return a string that's going to get set inside that index. And the reason that there's an array is because at the end of all this, we have to take all this string data, which can be quite large, and we need to concatenate it together into one string, and then we actually have to convert it to base 64. So it's a fairly expensive operation on the EVM to do that. You have to conserve memory on the EVM, even with when you're not running in a transaction. Technically the token URI function is a view function, so it's not a transaction and it doesn't consume gas, but there's still ways that it can fail. One of the only way that we've seen it fail, other than obvious things like infinite loops and things, is if you use too much memory. So by having these streams with an array of 24, it makes it easier to only set that string value once, and then when we concatenate it, we just have to allocate one buffer and then copy them all to the buffer. And as a side note, they're also pretty handy to have because you can see the layout. If you look at lines 9 through 19, even if you don't know Lisp, you can tell what it's doing. We have these 2 less than operators on line 9. We have several operators that generate XML, and so that's the parameter to that is a tag name, so that's generating an XML statement with HTML tag and so on. So at some point you have to save this. We make it very convenient for you to do your development directly from the web browser. We have a special function called token URI debug, and it works exactly the same as token URI, except it doesn't retrieve. It's running on chain, but it doesn't retrieve the contracts. It doesn't retrieve these scripts from the contract. It just takes whatever's in the editor that you see here. So there's 3 scripts that can get saved to the contract. One is the Give script. Another one is Fjord scripts, which is another. It's an array processing language that we provide, but we don't use that here. And then the third scripts are called external scripts, and this is just it's the JavaScript for your P5 algorithm. So when you save this, we have a button that does that. I'll do that a little bit later. When you save this, we're going to split this. We have a special separator here that you can see on line 26, and we'll put the Give script, and there's a method to save the Give script, and there's a method to save the external script. So when you're generating the HTML here from in lines 9 through 19, you can see on line 16 there's this special operator with the 5, and that's telling it to take the external script and put it at that point. So it's just going to copy everything that you see after this external divider, and that's where it'll put it inside your your HTML that you're outputting here. So again, the key is that the flexibility that Guive provides. Nothing's hard coded. You can generate whatever you want here. It doesn't even have to be HTML, but there's nothing hard coded here, so that's why it's trivial to use virtually any setup that you want for your for a generative NFT. So I'll save this now. Usually what your development process will be switching back and forth from this editor and then doing testing. And whenever you click the test button, it generates a new seed. So if you were using if you had variation dependent on the seed, which eventually you will, you would see that, and you can test a lot of your variations right from the editor. But for now, just let me save this. So I just click the save button, and the MetaMask is kind of popping up off screen here. So it's going to generate 2 transactions. I'll confirm the first one. That's going to save the Guive script. Confirm this one. So that one's confirmed also. So if I reload this page, you remember before our editor was empty, but now it will retrieve the scripts, if there are any there, and put them in the editor. So my setup has the reload's a little bit off the screen here, so I'm just going to pause it and reload it. So I reloaded it, and you can see that we picked up the scripts that we saved, and we do this. We put in this external separator, but yeah, you can see that everything's there. And if I scroll down and do a test, we'll see the same thing appear. So yeah, that's all I'll do for now. But just to mention that another really nice feature of Instant NFT is that once you've saved these scripts, you can mint you can do a test mint here, and then you can start integrating that into OpenSea directly long before you unpause your contract. So you can make sure that everything is absolutely 100% correct long before you have to unpause, and you can just keep experimenting as long as you want until you reach that point. So and I'll have another video showing how to do how to get this integrated with OpenSea on. But thanks for watching, and yeah, have some fun with Instant NFT.